Using data to approximate a continuous random variable, the first video. This is an intro, and we're going to, over the next couple of videos, look at these learning goals, use relative frequencies and histograms that we get from data to estimate probabilities associated with continuous random variables. And in this video in particular, we're going to use data that's already been collected to calculate the proportions of data within a certain interval from a continuous random variable to create a histogram. Okay, and we're going to start on those. But first of all, what is a continuous random variable and how does it differ from other types of variables? Well, the two main ways that we categorize them is whether they're discrete or continuous, and the previous video has been working on such as Bernoulli and binomial distributions. They're discrete, so as a rule of thumb they're countable, those sort of things, those quantities. So those sort of tasks are associated with the number of, okay, the number of people or the number of trials, a number of successes based on a number of trials, I should say, and things like that. So things that are countable. With continuous data, it's measurable. Okay, so if you can measure it, such as length and mass, things like that, that's continuous. And so a continuous random variable can take any real number value provided it's within an appropriate interval. Okay, so if we're talking about real numbers, okay, not just integers, not just positive counting numbers, I should say, but anything that's a real number provided it's within the appropriate interval for whatever we're talking about. Hence things like length. Okay, length can be to any number of decimal places. Of course, in the real world, the technology we're using or the devices we're using to measure things such as length are limited. That doesn't mean to say the variable itself is limited. It's not. So continuous can have any real number value within a certain interval. Now the data sort of thing that we were talking about, the data thing is a little bit synonymous to what you might have learned in junior when we were talking about the difference between theoretical probability and experimental probability. And another phrase that is equivalent to experimental probability is relative frequency, which we had there at the beginning of this video. Relative frequency. So that's based on certain categories, and that's how many times they occur relative to the total number of trials. Okay, now what we're doing is something a bit like that, and let's have a look at an example or two. Let's say this data here is the time it takes for a bunch of different people to assemble a simple toy. Okay, so you've got time and percentage frequency. And what if we had to find, if we wanted to estimate, based on this data collected, some probabilities? For example, the probability that the toy would have been assembled in this interval here. Now you can see the intervals in brackets. So t is the time. Okay, and so the probability that it took between 19 and 22 seconds to, if you chose any particular one at random, what's the probability based on the data, based on the estimate from the data, that the toy was assembled between 19 and 22 seconds. Now note the inequalities here, that's not a mistake. 19 onwards through to 22 exclusive. Now that has to exclude the 22, otherwise we'll be going into that part of the histogram which we don't want to. We're actually considering this part of the histogram up to and not including this line here. Okay, so we're talking about 1, 2, 3 columns, and we read the percentage frequency off, and so that would give us approximate, I'll write it down here, approximately 4%. So these are all in percentages. 4% plus 4.8, I reckon, plus 5.6. This is an approximation, and that's 14.4%, or as we often do, we write it as a decimal 0.144. So that's the estimated probability based on the collected data, and we would hope that the data is representative. Let's do one last one here. Probability that it takes longer, or 28 seconds or longer, to assemble this simple toy. Okay, so that means anything from 28, including 28 point something, like 28.3 or 28.22222, okay, anything up to the highest value out of the collected data, which you can see there is 31. And so we would have here 1, 2, 3 columns, and we read the values from there along the percentage frequency graph. So we have 9.6 according to what I can see, 7.2 and 4.8, with the sum of those, and that's approximately equal to, and that equals 21.6%, or the estimated probability is 0.216 in other words. More in the next video.